I'm going to explain about how to convert a context-free grammar to Chomsky normal form. But before going to that, we'll be talking about what's a grammar, types of grammar, context-free grammar, and Chomsky normal form, and how to convert context-free grammar to Chomsky normal form. And then we're going to solve a problem. First, we'll talk about grammar. What is a grammar? It's a set of rules to define a language, and it's denoted with capital G. There are 4 elements to define a grammar, and they are V, C, P, and S. V is a finite set of variables or non-terminals. T is a finite set of terminals. P is a finite set of production rules, and S is the starting variable of the production. The variables are represented using uppercase letters, and the terminals are represented using the lowercase letters, and all the other characters, which includes special characters. The production format is this way. Alpha defines beta. There are 4 types of grammar. They are regular grammar, context-free grammar, CFG, and context-sensitive grammar, CSG, and recursive grammar. The production format changes for the types of grammar. And now we are going to see about the context-free grammar. The production format for this is alpha defines beta, and there are restrictions for alpha and beta here. Alpha should always be a variable, which is the uppercase letters, and the length of the alpha should always be 1. And beta can be a variable or a terminal or a combination of both. Here are some examples for context-free grammar. First one, S defines A. This is alpha and this is beta. Alpha should always be a variable. S is a variable which is uppercase letter, and beta can be a variable. First one. Second one, A defines small a. Here A is a variable and the length is 1. Defines beta, which can be a terminal. Third one, A defines AA or small aa, which is a combination of both a variable or a terminal. It could be anything, a variable followed by a terminal or a terminal followed by a variable. Fourth one, S defines ASA. There is no restriction for the length of beta, so this is also a context-free grammar. Now Chomsky normal form. The production format is a variable followed by 2 variables. This is a variable followed by 2 variables, or a variable followed by a terminal. X is a variable. Now how to convert a context-free grammar to Chomsky normal form? For that we need to follow 3 steps, which are elimination of useless symbols, elimination of epsilon production, and elimination of unit production. First we are going to see about elimination of useless symbols. First we need to identify the generating symbols, and then we need to identify the reachable symbols. We will see this while solving a problem. Now elimination of epsilon production. Here is an example which includes epsilon. First we have to eliminate the epsilon. For that, first we should know what is defining epsilon. Here A defines epsilon, so wherever there is A, substitute epsilon in that place. We have A in S defines AB. We have A, so substitute epsilon here. First write as it is. S defines AB, capital AB and small ab. First write as is. Now substitute epsilon in place of A. When we place epsilon in place of A, will remain with B, and A defines AAB. Now elimination of unit production. First, what is a unit production? The production in the format a variable defines a variable is known as unit production. If you see anything like this, we have to eliminate that. Example, S defines A or AB and A defines A or AA. In this production, we have the unit production format, which is a variable defines another variable, which should not be there. So we have to replace A with this one. So S defines AA, which is this, and AB, and the rest is same. After we have completed the three steps, after eliminating all the things mentioned here, if the production rules are not in the format of in this format, which are the format of Chomsky normal form, then convert them by introducing suitable production rules, which we'll see in the problem. And now we are going to solve a question. This is a question given and we are going to solve it. By seeing the question, we see that there is a epsilon production which we have to eliminate, and here unit production B defines A, and we have to identify the useless symbols first, and we are going to do that now. First, elimination of useless symbols. In that, we have to find out the generating symbols. The terminals are always the generating symbols. First, write down that which are epsilon, A and B. Here, epsilon is defined by S, so S is a generating symbol, and A is defined by capital A, so A is also a generating symbol. This capital A, which is a generating symbol, is generated by B, so B is also a generating symbol. Now we got the generating symbols, which are epsilon, small ab, S and capital AB. Now identify the reachable symbols. Reachable symbols can be identified by deriving a string. Derive a string such that all of the productions are included in it. First, we'll take the first production rule, which is S derives ASB, and for this A derives AAS, and SB in here. Next, we'll define S. S is nothing but ASB. So I have derived a string A BA BB, which included all the production rules here. So we could reach all the symbols. So there are no non-reachable symbols here. All are reachable symbols. So we don't have any useless symbols, and we have completed the first part. Now the second part is elimination of epsilon production. As here we have S defines epsilon, so wherever you find S, you replace it with epsilon. So we have S here, so first write as it is. S defines ASB, which is this, and in place of S you substitute epsilon B, which is nothing but AB. Now A defines AAS. First write as it is. A defines AAS and A, and then substitute in place of S epsilon, which is AA, which is this. Now we'll derive this. B defines SBS, A and BB as it is, and now in place of S you substitute epsilon. First in this place we'll substitute epsilon BS, which is nothing but BS, which is this. Now substitute epsilon in this place. SB epsilon, which is SB, which is this, and in both places you substitute epsilon B epsilon, which is B, and we have eliminated the epsilon production. Now third step is elimination of unit production. This is a unit production. We have only one unit production. B defines A. So in place of A, you write this line, which I did this in place of A. Here there is A, so I have replaced A with this thing, AAS, AAA, and the rest is the same. We have completed the 3 steps, but here the obtained production formats are not as Chomsky normal form, which is this. So we have to convert them into Chomsky normal form by introducing suitable productions. First, we'll take S defines ASB. S defines ASB. There should not be 3 variables. There should be only 2 variables. S should define only 2 variables as per Chomsky normal form. So we'll take C1 as AS. So this is in the form of Chomsky normal form, a variable followed by 2 variables. Now take A defines AAS, which is C1 AS. In place of AS, substitute C1. It also should not be a terminal followed by a variable, so define another production format. C2 defines A. In place of A, substitute C2. This is in the form of Chomsky normal form. Now for all that, just define suitable production formats so that they are in Chomsky normal form. If you do all that, finally we could convert the context-free grammar to Chomsky normal form. This is the final answer. Check each are in the form of Chomsky normal form. See, variable defined by 2 variables. Here 2 variables, 2 variables, 2 variables, and a terminal. We check all, we could see it's in Chomsky normal form. So this is a way to convert a context-free grammar to Chomsky normal form.